Hello, in this video I am explaining working of single phase fully controlled AC to DC converter connected to RL load. AC to DC converter is a device which converts AC voltage source into a DC voltage supply by means of diodes, thyristors or transistors. These are also called as rectifiers. In this video, we are studying working of single phase fully controlled AC to DC converter. So fully controlled converters uses thyristors as a rectifying element. In converters, the output voltage is a function of the amplitude of the input AC voltage and triggering angle at which thyristors are triggered. Fully controlled converters are bidirectional converters. These are capable of providing output in the first quadrant of V0 I0 plane and second quadrant of V0 I0 plane. So let us study working of single phase fully controlled converter. So I have shown the circuit diagram of single phase fully controlled converter. It consists of a bridge rectifier which consists of all the four power electronic devices which are controllable devices. So in this bridge rectifier, we have used thyristor as a power electronic switch, which is controllable switch. Single phase AC supply is connected to the input terminals of bridge rectifier, and at the output terminals of bridge rectifier, RL load is connected. I have shown here the waveforms of output voltage and output current for firing angle alpha equal to 60 degrees and for firing angle alpha equal to 135 degrees. Now, as I have mentioned that this converter is a bidirectional converter and is capable of providing output voltage in first quadrant and second quadrant of V0 I0 plane. So, whenever we set firing angle alpha less than 90 degrees, we are getting output voltage positive and output current positive, and this corresponds to first quadrant operation. And when we set firing angle alpha greater than 90 degrees, then average output voltage across the load becomes negative and load current becomes positive, and this corresponds to the output operation in the second quadrant. So we have to study how we are getting these particular output voltages and output currents for these firing angles. So let us study working of single phase fully controlled converter. Now this is the input voltage which is given to the single phase fully controlled converter. Now, during the positive half cycle of a supply voltage, thyristor T1 and T2 are forward bias, but thyristor T3 and T4, these are operating in reverse bias condition. Now, from instant omega t equal to 0 to omega t equal to alpha, no triggering pulse is provided to T1 and T2. At instant omega t equal to alpha, triggering pulse is provided to T1 and T2. So T1 and T2 starts conducting and will connect a load to the source. So now current starts flowing from L terminal of a source through T1, through load, through T2, back towards N terminal of a source. With this, the current starts flowing through the load as shown with the direction in a figure. So this current, as current here is flowing from L terminal of a source towards N terminal of a source. So this current is considered to be the positive current, and the voltage which get applied across the load is the positive voltage. So this positive voltage is shown by the shaded waveform in the waveforms. And as the load consists of inductor and resistor. So during this operation, current starts gradually increasing from some minimum value to maximum value. With this flow of current, energy gets stored in the inductor. At instant pi, source voltage and source current will get reduced to zero. And after instant pi, both source voltage and source current will get reversed. But inductor in a load will try to maintain the flow of current through it in the same direction. And in this process, the inductor starts operating like an energy source and it will maintain T2 and T1 in conduction. Now from instant pi to pi plus alpha, current starts flowing from inductor of a load through resistor T1, N terminal of a source, L terminal of a source, T1 back towards inductor. Now during this operation, the energy stored in the inductor will get dissipated through the resistance of the circuit and the current in the circuit will start gradually decreasing from some maximum value towards zero. At instant pi plus alpha, triggering pulse is provided to T3 and T4. This will apply a reverse voltage across T1 and T2 and T1 and T2 are turned off. So from instant pi plus alpha, load will get connected to source through T3 and T4 and current starts flowing from N terminal of a source through T3, load T4 back towards L terminal of a source. So again, the direction of a current flowing through load is positive and this will apply a positive voltage across the load as shown by the shaded waveform in this output voltage waveform. So with this, the energy gets stored in the inductor. Current starts gradually increasing from 0 towards maximum value. Again at instant 2 pi, the source voltage and source current will get reduced to 0. And after that, the source voltage and source current will get reversed. But inductor maintain the direction of current in the same direction and hence it starts operating as a source and it will maintain T3 and T4 in conduction mode. So from instant 2 pi to 2 pi plus alpha, energy stored in the inductor is supplied back towards the source and current starts flowing from inductor through resistor R through T4, L, N, T3 back towards inductor. So during this operation, the voltage across the load will get reversed, but the current flowing through load will be maintained in the same direction. So after instant omega t equal to 2 pi plus alpha, again the same operations are going to be repeated. So if we observe these waveforms, then what we are observing that from instant alpha to pi, the output voltage is positive and from instant pi to pi plus alpha, the output voltage is negative. Now, in this particular waveform, if we try to find the average output voltage, then whenever this firing angle alpha, it is set to a magnitude less than 90 degrees, then average output voltage across the load is positive and average load current is always positive. And when we set firing angle alpha greater than 90 degrees, as I have shown here, the firing angle alpha is 135 degrees. Then what we are observing that the negative voltage appearing across the load is more than the positive voltage appearing across the load. And for this firing angle average output voltage across the load becomes positive, and load current is always, no, sorry, average output voltage across the load in this case becomes negative, and current is always positive. So due to this particular operation, a fully controlled converter is capable of operating in two modes. One is called as conversion mode of operation, and second is called as inversion mode of operation. So the first waveforms which I have shown here for alpha equal to 60 degrees, these indicates the conversion mode of operation. And these second waveforms which I have shown here for alpha equal to 135 degrees, this indicates the inversion mode of operation of a fully controlled converter. Now, what is this conversion mode of operation or inversion mode of operation of a converter? So, let us see a rectifying or conversion mode of operation. So, during alpha to pi, both the supply voltage and supply current are positive, and therefore power flows from AC source towards the load. During instant pi to pi plus alpha, output voltage is negative, but output current is positive, and therefore load returns some of its energy to the supply system. But if we see here, the net power is from AC source to the DC load as pi minus alpha, pi minus alpha is greater than alpha. If alpha is set less than 90 degrees, then voltage at the DC terminal, average voltage at the DC terminal is positive, and therefore power flow is from AC side towards DC side, and converter operates in a rectifier mode, and this operation corresponds to first quadrant of V0 I0 plane. Now what is the inversion mode? So inversion mode is explained with the help of this waveforms for alpha equal to 135 degrees. So for alpha equal to 135 degrees, the average output voltage is negative. If you find here average output voltage, then average output voltage is negative, and the DC power, and hence the mean AC power must be negative. The power is now being delivered from DC side of the converter to AC side of, of the converter. That means the power is delivered from load towards the source, and converter in this mode, converter operates as a line commutated inverter. The AC line current is displaced from the AC voltage by an angle greater than 90 degrees. It indicates that the mean component of power is delivered to AC side, and this mode indicates the inversion mode of operation of a converter, and this operation is related with the second quadrant of V0 I0 plane. This operation is preferred generally during regenerative braking operation of a motor which is connected as a load at the output terminals of fully controlled converter. So in this way, a fully controlled converter connected to RL load operates. Now one of the necessary condition is that if we want that the converter, fully controlled converter, it should operate in a inversion mode of operation, then it must consist of a energy source in a load. Then this operation will be possible. Now here I have shown the equations for of average output voltage and RMS output voltage. Now using these equations, we can find the average output voltage across the load, appearing across the load, and we can find the RMS value of load voltage. So this is all about working of single phase fully controlled converter connected to RL load. Thank you.